Hello, ladies and gentlemen. Hopefully you're having a good afternoon. This is Mr. Kitis, hoping to give you a supplemental lesson on elimination real quick. With elimination, what we're looking to do is try and get rid of a variable as quickly as possible. If you look at this system, you'll notice that here we have two variables of the x that are both of quantity 4, one positive and one negative. In the past, we've gone through and substituted by solving for one variable and then plugging it in. There's a more direct method we can use when the equations work out nicely for us. One of the key things for this method, just to keep in mind as we go through it, is that when you see something that's the same, we're going to subtract. And when we see something that's different, we're going to add. The idea here is that we can add variables and we can add constants. And if that's true, we should be able to add and subtract equations. So again, if we look back at our actual functions, we'll notice again that there's a negative and a positive, meaning they're different. So when something's different, we're going to go ahead and we're going to add the two. My suggestion to you is to put a plus symbol on the outside, cover with parentheses, and make it up like an old school addition problem. This will remind us what operation is that we're performing on the equations. When we do this, we'll notice that negative 4 plus a positive 4x will cancel. Negative 2y plus 8y will give us 6y. And negative 12 plus a negative 24 will give us negative 36. To finish solving for y, we'll divide by 6. And we're halfway done. All we have to do to finish this off is find the value of x. Remember, our solution is a point, so we need both. We can plug into either equation. I'll use the top. And simply substitute in the value that you've already found in order to find the other one. In other words, take the negative 6 and plug it in directly for y. So as we do that, we can solve. I'm sure that you guys, without my help, would find this value no problem. But if I had a little more accuracy, right? And there we go. So we found both of our values. We found y equals negative 6 and x equals positive 6. Okay? This is the basic process of what we're going to do. What I'd like to do now is go through several examples with you, both of the easy and the hard, so that you have everything you need to be prepared for tomorrow. So if we take a look at this problem, if you want to go ahead and try to solve this on your own without my help, it might be good practice. Go ahead and pause the video. I'll give you a moment. Okay. I'm going to assume that you've either solved it yourself or wish to watch first. Again, if we look at this particular problem, we're going to notice that we have two different things on the variable that matches up. And again, it's super important that we look at the fact that we have the x's that have the same coefficient, one positive, one negative. Before we said if it was different, we were going to add, so let's go ahead and follow through. Same idea as before, we're going to add the functions. Again, the x's will cancel, and everything else just like normal addition. So 5y plus 4y is 9y, and 1 plus a negative 10 is a negative 9, excuse me. Just divide, and you found one of your values. It's really that simple. Okay. Again, just like before, you can pick either equation, it doesn't matter which, to plug back in and find the value of x. I'll use the bottom this time. Give it a little variation. So again, same idea. Take that value and plug it right in for your variable. Okay. And again, I know you guys don't need my help to do this, but for completion's sake, I'll solve it out step by step. If I'm going too fast, go ahead and pause the video at any time. This is for your assistance. So our x value is negative 1, and our y value is also negative 1 in this case. Now, these are two pretty easy examples. There is one wrench I can throw at you, as is always the case. I'll go ahead and show it to you now. I will note that if you want to give this a shot, you're more than welcome to pause. And if not, I'm going to keep going. We said before in our early two examples that we wanted one of our variables to match up, almost like a common denominator. In this particular problem, there isn't one. What we can do though is we can look at the coefficients that we have and try to get them to match. So if we're looking at this, we notice that there's a pretty easy step to sort of match up the -3 and the 9. Okay? What we could do is we could multiply 3 by 3 and get a 9. Now, just like addition and subtraction, if I can do it to variables and constants, I can do it to a function as well. And my suggestion for how to write this to make it a little simpler is to draw 2 arrows. And on each of those arrows, write the operation that you're going to do. So for the top, we want to multiply by 3. On the bottom, we really don't have to multiply by anything. We're just going to recopy the function. Now, if I do this, it's important to remember that this positive 3 needs to be multiplied by all the things in the upper equation, almost like we're distributing it. It has to be equal. So 3 and -3 will give us -9. 3 and 7 will give us 21. And 3 and 16 will give us, what, 48? 30 and 18, yes. On the bottom, again, we're not changing anything. Okay? Now here, if you take a look carefully, you'll notice that we have a new case. In the past, we've had everything that where our matching variable was different. Here, they're the same. So to do this, I'm going to have to go ahead and subtract the equations. Now the idea behind this is simple. I'm going to set up the same way I did before. And I have to recall that this negative is going to hit all of my equations. So if I want to write it out sort of in shorthand, I can sort of note that this negative is going here, here, and here. I can simply make that adjustment directly. So if I make that a positive, it cancels that to a positive. This becomes a negative, and this becomes a negative. Oh, hold on. Wouldn't be a good video if something didn't go slightly off. Okay? And now that we've applied the negative to all 3 terms, just like it was a distribution, we can add just like before. So -9 and +9 will cancel. 21 and 5 will give us, since it's a negative, will give us 16. And -48 minus 16, -58, -64? That looks correct. I hope. So if we divide by 16 on both sides, we're going to get 4. Oop. Right, because 32 and 32 is 64, and 16 times 2 is 32. Now, just because we did multiplication doesn't mean anything has changed. We can pick any of the equations that we've created or been given to find our second value. I'm going to choose the one from up top, right over here, because I think that that's the easiest one to solve from. And then we'll go ahead and plug it in directly. So here we'll take the -4, just like in the past. We'll go ahead and plug it right in for y and solve through. So 28 and 16 sounds like 12, which is going to lead us to -4. Okay, so those are our 2 major values. So as a quick wrap up, you want to make sure that one of your variables matches up. Once they do, and you may have to multiply, you need to add or subtract in order to eliminate the 2 functions. Remember, if they're the same, you'll subtract them. If they're different, you'll add. And at the end, you need to plug in to find the value of the second variable and get them both. Happy solving.